Now we're going to use that data from video physics and make some graphs using numbers. All right, for starters, I want to note that this looks a little bit different than where the last video left off. In the last video, I only had 4 points, and I really want 6 points. I can get probably a better line out of having 6 points. So I did go back in and drop 2 more points so that I have 6 pairs of displacement versus time. All right, next I'm bringing it into Notability, and I'm going to crop it, make it big so that I can read my data pairs, my time displacement and my velocity time data pairs. Next, I'm going to get 2 tables ready. I'm going to have a table for part 2A, which is going to be displacement versus time, and a table for part 2B, which will be velocity versus time. And I'm just going to do a little time-saving trick here. Because my times in parts, both of these tables are going to be the same, I'm going to read the times from the 2A graph, that's the displacement versus time graph, and then just copy those over into part 2B because, again, the times are identical. Okay, so let's look at those tick marks. If I look at the x-axis that has time on it, and I have 0.4 and then 0.6, so halfway in between there must be 0.5 seconds. So I'm going to kind of mark that 0.5 seconds in there, and then if I mark halfway in between those 2 remaining, I can get tick marks such that I have 5 tick marks between 0.4 and 0.5 equally spaced, and 5 tick marks between 0.5 and 0.6 equally spaced. So that means each of those is 0.2. So I'm going 0.42, 0.44, 0.46, 0.48, etc., and then 0.50, etc. So and then what I'm going to do is draw a line from my point down to my tick marks just to help me get a better read on it. And I'm going to do my best to estimate to 3 sig figs the value of the time for each of those 6 data points. Now I am going to put those values for the time into my table for part 2A. Get my time up there, my label, and then I'm going to copy and paste so I have a start on my table for part 2B. Next, I'm going to use kind of the same procedure in reading my displacements off of so they're delta x's, they're my displacements in meter, but they're plotted on the y-axis in this graph. I'm going to read those values. So again, I'm going to be mindful of looking at my tick marks and what is between each of those tick marks, and I'm going to read these to 3 sig figs, and I'm doing it by drawing a line from the data point straight over to the axis because that makes it a little easier to get a good read. Then once I'm done drawing all of those, I'm going to put the data points into my table. All right, now we're going to look at the bottom graph, which is the velocity in the x direction in meters per second. So I need to make sure I put that unit in my table. So that's on the y-axis, the velocities, and the x-axis are the times, which are identical to the times in the previous graph. So I need to read those velocities, being mindful of my tick marks. So I'm looking really carefully. Those tick marks start at the bottom at 6.9, and then it's tick, 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 and then 6.95. So each of those tick marks is 0.01. So I wrote a couple of them in there. I didn't write them all in there. So it goes 6.91, 6.92, 6.93, 6.94, 6.95, etc. So each of those tick marks all the way up on the y-axis, which are the velocities, are changing by 0.01 meters per second. So I'm going to read those off and record them in my table. All right, so now we're going to enter our data into numbers so that we can make a graph. If you need to, look at the video from last week for more detail than this video gives. Be sure to put the data that you want on the x-axis in the first column. In this case, we want the time to be on the x-axis, so put it in the first column and the displacement in the second column. All right, and then we're going to make a graph with a trend line just like we did last week. So same procedure. This video does not show giving a title to this graph and does not show labeling the axes and including the units, and be sure that you do that. As you've discussed in class, if we have a graph that's displacement versus time, my slope will be the velocity. And if my displacement is in meters and my time is in seconds, then my velocity is in meters per second. Okay, so we're going to do our final graph now. We're going to take the data from that table we made that was part 2b, and we're going to enter it into numbers, making sure that we put the thing that we want on the x-axis, that's time, in the first column. So I'm going to put time in the first column, and I'm going to put velocity in the second column because I want velocity on the y-axis in this case. And again, I'm going to use the same procedure of creating my graph and getting a trend line on the graph. Hey, so let's look at the slope for this graph. It's not 0, is it? What would I expect it to be? This was supposed to be constant velocity, right? So that would mean 0 acceleration. It was close, but the car must have been accelerating a little bit. If this is constant velocity, we anticipate that slope of the velocity versus time graph should be 0. If yours is a little bit off of 0, but that's okay.